Hi, I'm Steve Sherman. I'm here tonight to film a video to actually show you a new construction design for the extreme minimal agitation tubes. And I want to just show you what I have used in the past. I think you folks have seen this in the EMA video. I have an O-ring here, and I have just a cap, no threads or anything, and this is the way I would agitate it. That's proven somewhat problematic in that chemistry can slightly spill out, but the biggest concern is that the piece of film can actually shift inside of here, and I don't want that to happen. So along comes this mechanical test plug that I was able to find again at Home Depot. It's made by Titan. It will fit in a piece like this. You just tighten it like this, and as you've seen in the video, I've held 2,200 milliliters of water watertight. So this, I'm going to actually go through cutting this piece, gluing it, everything. Hopefully in a matter of 5-6 minutes, you're going to get an end product tube, finished tube, ready to go. Alright, so here's all the products lined up that we're going to need for this project. First is some safety glasses for obvious reasons. We're going to be using a saw. This is a piece of the Schedule 40 electrical conduit. This is the end cap that I chose to have round as opposed to having ribs or ridges on it so that I can roll it. When I'm completed, this is a piece of 220 grit sandpaper. I just want to take off any burrs that might have happened from manufacture and also from the fresh cut that I'm going to make. This is PVC glue. It comes with a purple primer that you must put on the plastic, the electrical conduit prior to the glue. This is the glue. It sets up very fast. So I have a rubber mallet that I'm going to put that cap on, and I'm going to send it home. One quick hit to set that down. Then in a matter of minutes, the glue will be dry. I'm going to take a cylinder hone, and I'm just going to put it inside, and I'm just going to slightly turn it like that, go up and down, and remove any burrs that may be in there. And finally, this is a test cap, the mechanical test plug that I'm going to use. You've already seen this in other videos where it's very, very watertight, and it's really been a blessing and has given birth to this new design tube.
Steve, what size do we cut the tubes to?
That's a good question, Peter, and after a lot of back and forth with present video subscribers and a lot of math that I did on my own, I've determined that a 3-inch tube is perfect for, or the best option for 4x5, 5x7, 8x10, and 7x17. 11x14, I have a client in Scotland that's using a 4-inch tube, but nevertheless, the 3-inch tube. Let me just outline this for you. 4x5, you would put the film horizontally, so the 4-inch side would be 4 inches high. If you were to cut your tube length 6 inches, you're going to lose 125 milliliters of solution with this cap. So a 6-inch by 3-inch tube gives you 695 milliliters of solution in that 3-inch diameter tube. So you take away the 125, you're down to 545 of solution. I think you could knock it down to 525 in that area, and you're right at that point of where the recommendation that I gave you of 3 milliliters of A, 2 milliliters of B, and you'd be right where you need to be. 5x7, I've been using this this 3-inch tube design for a long time. I believe I'm going to make a new and improved version right here tonight for you folks. 8x10, it works perfectly with 8x10 and 7x17. So I think the key is that 4x5. You don't want to take 4x5 and put it in a 2-inch tube, because now you're going to drop down in the low 300s of milliliter solution, and that is too problematic, number one, to measure, and number two, some clients, some subscribers have tried that, and there's just simply not enough inherent developer in the actual 300 milliliters of solution. So this leads me to suggest to everybody that they use a 3-inch tube. So I just want to reiterate before I cut this. I'm cutting this for 5x7 film, but let's say the majority of you folks are using 4x5 film, and I suggested 6 inches. Remember, the EMA, the test plug is going to take up 125 milliliters of solution, and I have said in other areas where you can't, in a 3-inch tube, a normal man's size of his hand, you really can't get much more than 2 inches down to grab that edge of the edge of the piece of film. That's why I'm saying a 4-inch high piece of 4x5 film, 6 inches high is maximum. You could drop it down to 5.5 if you want. That's your call. I'm just giving you the know-how as to how to do this. In the PDF notes, I've actually included a terrific little volume calculator. So without any further discussion, I'm going to put my safety glasses on. I'm going to cut this piece of Schedule 40 electrical conduit. Now, obviously, you don't have to run out and buy a chop saw to facilitate this. If you did buy your Schedule 40 electrical conduit at Home Depot, they do have facilities to cut it to whatever size you want. So don't let this become an obstacle. All right, all set. So, as I said before, I'm going to take my 220 grit sandpaper and I'm just going to take off any little sharp burrs that the actual chop saw may have put on the edge of the plastic. It really is not going to take very long at all. At this point, it's all ready to glue. I'm going to wipe any dust off it like this. And one thing to say, for you folks that are actually 4x5 film users, you're going to have a tube that's 5.5 to 6 inches long. You could just run your hand inside and out, bottom and top of the tube, and not have to buy a $12 or $15 cylinder home like I have.
So Steve, now that we've got the tube cut to size, you've cleaned it, you've taken all the burrs out of it, what's the next step?
Next step is going to put the purple primer on. It should have a little applicator brush in here. All you do is put this on the surface that you're going to glue.
So this is prime and also cleans the plastic, is that right?
Yep. I imagine there's some kind of a chemical in here that is conducive to the glue acting very fast. That is the one little area that you need to be really prepared for. Once you get this glue out and on the two surfaces, you always put it on both surfaces. Once you join those two surfaces, I'm going to pick it up very quickly. I'm going to give it a wrap, and my hope is that it's going to be plumb. If you follow what I mean by plumb, that when this thing is setting down on a flat surface, this thing is going to be plumb and not leaning like this. I'm exaggerating, but okay. So we're all ready to go. I'm putting the glue on. Put it on fairly generously. And as I say, it's very important that you put the glue on both surfaces. Peter asked me before if this glue had ever shown any kind of problem with, give it a little bit of a turn.
Press and hold.
Give it a little bit of a turn with friction. That's always the way you set glue. And you know, within 30 seconds this thing should be set up. And you are going to have a light or a waterproof base that will hold your chemistry. It's standing nice and plumb. So just to finalize the measurements, when I glued the cap on, the actual tube grew 3/4 of an inch. So take that into consideration when you cut your own. So if you want a 6-inch tube, cut it 5¼ inches high. All the glue, the actual depth and thickness of the cap itself is going to take up approximately 3/4 of an inch. Okay. Now I have my cylinder hone. I'm going to get it inside by just compressing these 3 springs.
And what is that doing again, Steve?
This is going to deburr any manufacturing defect that's inside the tube itself. Obviously, you don't want the backside of your film to be scratched by some type of a sharp object that you're not aware of. So this is a very easy way to eradicate that. All right, so what we have here is our final tube has been cut. It's been glued. I've deburred it with the cylinder hone. Now, just to put your mind at ease, when I run my finger in here, I can still feel slight variations in elevation, very, very minor. There's nothing sharp left here. This doesn't have to be perfectly surgically smooth. It just has to be free of burrs, okay? So it is now ready for our mechanical test plug, 3-inch test plug. It's a compression type of arrangement where we're actually taking a rubber collar and tightening it so that it expands out against the cylinder wall, and that's what creates the seal. And as I showed in another, at least I think it was a still picture, it actually held back 2,200 milliliters of solution. You're only going to have 500 or 600 in this arrangement. So it's a terrific new way for me to design my tubes. Now,
Steve, I don't want to mess with all this chemistry. What else can I do?
well, that's a good question, because one of the extreme minimal agitation video subscribers came up with an idea. He uses the test plug that I'm using on the top, but he bought this other means to cap off a 3-inch diameter tube. It's nothing more than a rubber cap with a big hose clamp around it. He puts it on the bottom prior to putting chemistry in, puts it on the bottom, tightens it up, goes through the whole 6, 20, however many minutes you're going to agitate. When he's done, he unscrews the bottom. The film is right there. All the chemistry goes out. The film is right here. You can just gently extract it to your stop bath and onto fixer. For those of you that want to take this off, pour out the chemistry, pour in stop bath, I don't see a problem with that either. It's just not the way I do it. So we have a finished tube here in probably 6 or 7 minutes when you cut out all the explanation. Wash this tube out thoroughly, and you're ready to process film. I just want to take another opportunity to reiterate once again: adjacency effects are a result of developer exhausting. Without the developer exhausting, you will not realize adjacency effects. PyroCap by itself is a much superior developer than you may have already been using. If you haven't been using PyroCat is a significant step up. So you may see a noticeable difference in your film, but if you're not exhausting the developer, you're still not realizing what I am with adjacency effects. You need to exhaust developer. And one last time, and that is why square inches of film based on total volume of chemistry in solution is so important. 4x5 is going to have its own unique formula. 5x7 is going to have a different formula. 8x10 is going to have a different formula. And therefore, once you arrive, no matter what tank you use, the SP445 tank is 500, from what I understand, is 495 milliliters. That's perfect. One sheet of film. It allows you to develop 4 sheets of film in that SP445. You can't put 2 sheets in because 2 of them are identically exposed. It doesn't work that way. It's based on developer exhausting. Obviously, more square inches of film, the faster it will exhaust. Email me with any questions that you might have. Hopefully, this gets you all on a fast track to experience adjacency effects.